step by step. You don't have to sketch a graph or look at a graph or anything, which can be a little bit harder to figure out. So finding limits. These are limit rules that you need to learn and memorize and be able to use. And so I'm going to give you all these rules that I'm going to show you how to use them. So finding limits analytically or using algebra. So here are some basic rules for finding limits. Basic limits that we know. And what we know is that B and C are positive real numbers. Well, they don't even have to be positive. B and C are real numbers. And N is a positive integer. Okay, now when I give you rules, these are general rules that we can apply to all limit functions. So we write them generally with letters like X's, A's, B's, and C's. So X is typically your variable, Y is your like f of X, and A's, B, any other letters in there are just meant to represent constants. All of these represent numbers. B and C represent any real number. N is a positive integer, okay, -2. Or not a positive, like 2 or 4 or 1. So here's rules that we know. Number one rule that we know, the limit as X goes to C of B is equal to B. The limit of a number is that number. Okay? This function would be the function y equals B. Y equals B is a horizontal line. The limit of any horizontal line as x goes to 2 or 4 or 57 is whatever that horizontal line is, isn't it? The limit as x goes to 2 is whatever that y value is, which is the value of that b. Okay, so the limit of a number is that number. The limit as x goes to anywhere of a number is that number because it represents the graph of a horizontal line. So that's the first rule you need to know. Rule number 2. The limit as x goes to c of the function x, well, x is the equation y equals x, or f of x equals x, which is just a line, okay? And that's equal to c. So here's what the graph of that looks like. The graph of that is that line that goes through the points 1, 1, 2, 2, 3, 3, -1, -1, -2, -2. So the limit as x goes to 2 is 2. The limit as x goes to 3 is 3. The limit as x goes to -1 is -1. Because every y value and every x value are equal. There's another limit that you need to know. Okay, number 3, the limit as x goes to c of x to the n, a function like f of x equals x squared, okay, y equals x squared, is equal to c to the nth power. So if I wanted to find the limit as x goes to 4 of x squared, what is this basically telling me to do?
Just 4 to the second power.
Isn't it basically saying, hey, to find this limit, the limit as x goes to this number of this function, replace the x with what? C. That's all it's saying. Look here. Isn't this saying the same thing? The limit as x goes to c in this function, replace the x with c. That's all it's saying. So this would be 4 squared or 16. All right, so now there are some properties of limits that you need to know as well. Properties of limits, these are all in your book too. So when we're dealing with properties of limits, here are things that we're given. These are things that we know. We are saying that we have the limit as x goes to c of some function f of x is equal to L. So these are what we call our givens. Did you do proofs in geometry? Given, prove, given this, prove that? Okay, we don't have to do proofs, but we will. That's the biggest part of math, especially when you take college calculus, that we don't get to do here, is a lot of proofs. I took one whole geometry class in college and it was all proofs. And it was non-Euclidean geometry, and in non-Euclidean geometry, parallel lines can cross each other. Why you need to know that? I like to know how things work and why things work. Have you ever asked your mom or dad why? Okay, you want a proof. You want a proof. They just, yeah. They want to tell you you want them to tell their thought process, and you want to find their flaw in their thought process so you can argue and say, there you go, right? Okay, so we just do that with math. Okay. All right, so here are our givens. This is what we know. The limit as x goes to c of the function g of x is equal to some other number. Okay, don't try to make this confusing. They're just saying, I've got a function, I don't know what it is or care, and as x goes to c, its limit is equal to some number L. Okay, I've got some other function, g of x, and if I take its limit as x goes to c as well, it's got a different limit, k. All right, if I have these two things, then here are the properties of limits. The first property is called the scalar multiple property. And it is the limit, it says that the limit as x goes to c of some number b times the function f of x. Okay. So let's say I want to take the limit as x goes to c of f of x, which I already know the limit as x goes to c as, but all I'm doing is multiplying it by some number out front, like 2. Well, that's the same as just taking 2 times the limit that I already know. So here's a quick little example. The limit as x goes to, let's say I know the limit as x goes to 2 of x squared. What's the limit as x goes to 2 of x squared? Using our other rules that we just learned. Plug 2 in for x. All it's saying is to find a limit, you plug the number that x is going to in for the x in the function. It's that simple. So that would be 4, right? So we know that. So what if I wanted to find the limit as x goes to 2 of 2 times x squared? How about I just take 4 times 2, because isn't this function the same as that one multiplied by 2? So this rule is saying I can just multiply that times the limit and get 2 times 4 or 8. Or yes, you could just plug 2 in there and work it out, either way. So some of the properties aren't like necessary to use, but they're nice to know. Okay, the next property is called the sum or difference property. And this says that the limit as x goes to c of the sum or difference of two functions is the same as the sum or difference of their two limits, if you were to work the problems out separately. The product rule is a really nice one. The product and quotient rules we'll use a lot when we do some crazy trig limits tomorrow or Thursday. So the product rule says that the limit as x goes to c of the product of two functions, f of x times g of x, would be exactly the same as multiplying the two limits if we would have found them separately. The quotient rule. Yeah, I'm going to go fast because this is something you should have read. And it should actually already be in your notes. So, Because when you read, you should also take notes, remember, on the things in the boxes, and so. All right, so the quotient rule says that the limit as x goes to c of f of x divided by g of x, how could you find that if you knew both of those limits as x goes to c? Well, what did we do when it was adding and subtracting? Didn't we just add and subtract the limits? And when it was multiplication, didn't we just multiply the limits? So what do you suppose when it's divide, what do we do with the limits? Divide. All right, and finally the power. The limit as x goes to c of, say, f of x to a power, well, in keeping with all the others, it would be that limit to that power. All right, so now we have a couple of other little limits of polynomials and rational numbers. And rational functions. If I have the limit as x goes to c of p of x, p of x is a polynomial. Who knows what a polynomial is? What does the word polynomial mean? Okay, Drake, could you say that a little louder?
X to the nth term plus 2x plus 1.
Okay, so you've got things with exponents, right?
Yeah.
Like, isn't an example of a polynomial like x cubed plus 4x squared minus 7x plus 1? Poly means many, many terms. Polynomial, many terms. Okay? So the limit as x goes to c of some polynomial p of x is equal to this. Watch this. P of c. What is that telling you to do? Plug in c for x to find the limit. So if I wanted to find the limit as x goes to -1 of x cubed minus 3x squared minus 6x minus 12, how would I do that? Plug -1 into all the x's and follow the order of operations. So I would take -1 cubed minus 3 times -1 squared minus 6 times -1 minus 12. Guess what? This is the hardest part. Yeah, I know, it shouldn't be. So what's -1 cubed? -1. -1 squared times -3. Okay, -6 times -1. And then minus 12, so -1 minus 3, that's -4, plus 6 is 2, minus 12 is -10. I don't care how you did it, type it into your calculator. So what is the limit as x goes to -1 of that function? And it was as simple as algebra, plugging the -1 in for all the x's and working it out. All right, so the limit of rational functions, the limit as x goes to c of p of x divided by q of x. That's a rational function. It means it's a fraction. A rational function means it's a fraction. You've got x's all over the place, top and bottom. How do you suppose you find that limit? P of c divided by q of c. In other words, you just plug c in for all the x's. So let's say I have the limit as x goes to 1 of x squared plus x plus 3 all over x plus 4. What are you going to do to find that limit? Plug 1 in for all the x's. So 1 plus 3 is 5 over 5, so the limit is 1. All right, there are more, there's lots of theorems in this section. There's a theorem on limits of radicals, okay? Theorem 1.